All right, so I'm here tonight to talk to you about rapid prototyping, which is something that we do a lot of in my lab at Site 3. And it's a thing I think about all the time because it's often projected as being the future. What we deal with here is we're dealing with the challenge of when you can make something perfect every time the first time, what value does that thing eventually come to have? And what we have on this slide here is a beautiful hand-carved, oh, that's an ivory ball versus something printed in sintered steel. So this is the new normal, the MakerBot replicator. Many people think this is the future, and I don't actually think that the MakerBot replicator is the future, and not just because they're being sued. I think that it's because this is too perfect. I think that this is a toy. I don't think it's a tool, and I don't think that the future belongs to toys. So what is 3D printing? 3D printing is a process by which you superheat powders or print out ABS plastic, and you make a form that could not possibly be achieved by human hands. Bathsheba Sculpture is my favorite person who does this right now because she does things like Klein bottle openers. I think that's funny. I think that art is better when it's funny, because art is better when it's funny. So what gets lost? This is a hand-carved ivory puzzle ball. It's from China. We used to have these in my mother's curio cabinet. It was a Wunderkammer, which is a tradition from Germany where you collect magical treasures and you keep them in cabinets and you display them because they are beautiful examples of handcrafting, and you can see them at places like the AGO, these treasures from the Wunderkammer. And that used to be how things that are as intricate as 3D printing got made. But now we make them with laser cutters. Now, I love laser cutters. When I was 6 years old, my mother brought home some laser cut glass from Corning, New York, and it was the most perfect thing I'd ever saw, and I really just wanted a laser cutter for myself. But laser cutters are not inherently exciting. They just burn shit. That's what they do. They burn it, very exactly. They are for making a mess. They're for making a very constructive mess. You can make the mess very exactly and very precisely, and you can make the same mess again and again and again and again and again and again and again. And that is what rapid prototyping is when you get through all of the mess fast enough that you can ship out the thing that you want to make to China and have it brought back, and it will be perfect, and you will make 100 of them, and they will be perfect. And that's what they're for. So, alleged rapid prototype sketch. I see that the rapid didn't get put in there. This is a sketch for some pigeons that I did. So the first thing that I did on my laser cutter was decide to figure out whether or not, yes, I own a laser cutter. It's mine. Other people use it sometimes. Then I get annoyed. There are 40 of them. There's one of me. So what that sketch turned into was this. And what a laser cutter does is more mess faster. So this was the first thing that I cut on the laser. And the thing is that the laser cutter didn't teach me to draw. It didn't teach me to think. All it did was allow me to make more mess faster. I could have cut this bird by hand using a jigsaw, but with rapid prototyping, what you get to do is trick yourself into believing that you are not making it by hand. And that might make it easier for you to make the thing. You can make a thing faster and better if you think that you're not making it by hand. But you cannot escape your materials. They will change how you think about what is possible, but you can't escape your materials. If you are making a thing, you are still making a thing in the real world, and those materials begin to matter. This is a photo that was cherry wood. Moving on, what I've actually been rapid prototyping is multiple colors of fire. Here's where we get to the flamethrowers. Via the internet, flame test. This is because I threw a deck together out of a bunch of stuff I'd rapid prototyped. And the first thing I've been rapid prototyping is flamethrowers because I do a lot of work with interactive flamethrowers. I'm most well known for the heart machine. That's what everybody's been coming up to me and talking to me about tonight anyway. I was working on a gun that shoots rainbows. Why? Because it's awesome. That's why. It's funny. So rapid prototyping is how you take something from a sketch and you make it into a real thing through an iterative process, which means you fuck up a lot and then go back, and then you fuck up again and then you go back. And the idea here was that we would be able to change colored fire on the fly, because ultimately fire is just another blinking light. And that's the problem that you get to after you get your gas fitter's license and you can plumb whole buildings, is that you just sort of turn it on and it's orange. And you're like, well, it's 30 feet tall and it's using 500 pounds of propane, but it's still just orange. So I thought, hey, maybe we could sketch something and we could get a really cool futuristic weapon. But the thing about rapid prototyping is it is not what you are going to actually get. It's a series of mistakes that you make so that you can get past the blank page. This is a picture of me getting past the blank page. Portrait of a Searle. I was a Searle because it was not working. This is what the pretty drawing that previously went looks like in prototyping. You will note that there's a lot of waste there. That is because rapid prototyping creates a lot of mess and it creates a lot of waste. Getting your hands dirty is more important to the process than the laser cutter. But the laser cutter is how you will trick yourself into believing that you are not going to get your hands dirty. The 3D printer is how you trick yourself into believing that you are not engaging in sculpture that the ceramicist down the street totally had locked before they were 17. That's how you do. So I designed a bunch of things for this rainbow flame cannon. One of them was the original switches. Look, they're beautiful. And look how they're beautifully sitting and making a beautiful picture on a piece of steel. And that is all they ever did. I never wired them up to anything because I designed them independently of the cannon itself. So they never turned anything on because they wouldn't fit properly. This is the second prototyping sketch. It is a lot more accurate because it is simple. Prototyping things teaches you to keep things simple because the simpler they are, the less waste there is. Because prototyping is expensive, and rapid prototyping is more expensive faster. Incremental improvement is expensive. This was with the help of Erica from Ace the Tech Studio, who came in and looked at what I was doing and said, so why haven't you used a router yet? And I said, what is a router? I don't know what a router is. And then she helped me. She helped me put it together, and she helped me fix it. And so this was, I think, version 3. This is version 5. There you go. That's another more attractive photo. This one actually worked, except that what happened was that it rapid prototyped itself into a cube of green fire that backwashed over the solenoids, which did not explode. How did I do this? Through the help of my community and public funding. I applied for a bunch of grants from people in the States, and they said, you're doing what? Here's some money. This is funny. So the conclusions jump to, if you do rapid prototyping, if you put together things and you actually get your hands dirty and you build it, if you test it, it will work eventually. That is it working. Look, it turns green. It is extremely dangerous to work with machine tools, but less so for the different reasons than people think. It's very dangerous to work with fire, less so than people think for different reasons. I forgot the last one, but questions or feedback? You can tell I put this deck together maybe not in the best mode. That's what happens when you have to answer really specific questions. From City of Toronto fire personnel, because you've been testing in the alley. I would recommend that you test your project somewhere else and that maybe you don't work with explosives. Thanks.